Hello, this is the Managing Machine Learning Projects course project. In this course project, we're building machine learning models capturing plantar pressure and gait analysis for patients. And then basically we will compare different evaluation methods across different type of machine learning models and try and see which one works the best. So the problem statement we're trying to solve is we're basically trying to build a systematic review and understanding of leveraging different machine learning models for analysis of plantar pressure, basically foot pressure distribution, such that it gives us correct insights into foot functions, movement mechanics, and foot injury related issues. Problem you're trying to solve is customize wearable footwear devices, capture data, but lack of appropriate ML models and subsequent analysis often results in what we call delayed insights into foot functions. This is highly beneficial for sports persons with injury-aged people and specific sections of society, for example, pre-diabetic and diabetic patients who are very high risk of diabetic ulcers and feet. Can ML help solve it? Yes. So there are multiple ways you can solve this. Some of the approaches in the classic ways is basically use simple machine learning methods. But recent research has shown that ANNs, artificial neural networks, specifically different types, include multi-layer perceptron models, convolutional neural network models, and recurrent neural network models. The most frequently employed artificial neural network algorithms across the recent reviewed studies. So the CRISP DM business understanding is as articulated sports persons or folks with foot injuries and diabetic patients target user. We are trying to basically prepare a systematic review and understanding of different ML models and understanding why this matters, because it will help in preventive, not only effective prevention, but also coaching strategies and promote optimal foot health and performance. Currently, it's basically done using simple machine learning models, but we are trying to see if evaluation methods across CNNs, RNNs, and GANs provide better result and output. Better diagnosis of patients and faster recovery time is the key objective here. But definitely there are certain constraints. For example, the sample size, the outcome variables clearly defined. Is the experiment data set appropriately been used? Is the correct ML model being used for evaluation? And then are the techniques correctly used? Then these are important constraints for the study. Simple algorithms often employed for classification regression task, right? I mean, they provide outcomes like random forest, naive Bayes, fuzzy logic, but they have shortcomings for accurate finding. Hence, we have kind of moved and tried using artificial neural networks for this particular study. The three top ones, which we are prominent ones, which have used multi-layer perceptrons, convolutional neural networks, and recurrent neural networks. Output metrics is basically accuracy, the precision, the sensitivity, or the recall of evaluation methods or the metrics, and basically performance metrics for the model would be k-fold cross-validation is the one which we are aiming for. And identifying potential relevant factors, yeah, there are multiple. We have shortlisted to identify a few of them. The evaluation of population, correct sample size is important. Efficacy of the wearable devices, which we're going to talk about later, is very important for accuracy of the data collected, hygiene, and then the pre-data collection evaluation technique and post-data evaluation technique. These are all important factors for this particular study. So these are important. We have basically developed a solution validation plan where we have planned to execute a series of what we call iterative experiments, right? So they're basically divided into four steps. First is to identify the correct ANN algo. And then how do we do that? By categorizing them based on their application and efficiency in image processing and time sequence analysis of sensor data. By bucketing different type of sources. So we are basically aiming for EMGs, cameras, force plate, magnetometers, gyroscopes, and accelerometers. And then we will have data level and a feature level comparison across different ANN algos. And which algos are we using? The three ones spoken earlier. And examine the different evaluation methods of these ANN algos, and then we will summarize the different evaluation methods based on performance scores. That's the objective. And then we will identify gaps and challenges and provide recommendation for the future analysis. And of course, we have defined a system design The requirements is mid latency, does not require constant connectivity, and privacy is very important. However, system design could be hosted on cloud as long as it's a single tenant service. Going to privacy will definitely take care of offline learning, and batch predictions will work fine for us as well. Potential risks in production, there are a couple of them. A notable trend that we have seen is using shared online data sets. So this pattern underscores the challenges inherent in gathering patient-specific data for research. So this is an important thing. Pressured data collection devices. Now there's a dichotomy in data logging devices and then comprising both commercial and custom designed footwear. So the data, the way they are collected, and also the accuracy, resolution, reliability, they all differ, right? So we have to ensure that the collection devices are accurate for a particular given study. Latency and inconsistency. Now we need to integrate data from whichever ones we collect, the previous step, either like commercial or custom design footwear, but then they need to be integrated for a comprehensive analysis, right? So this adds an additional latency plus a layer of complexity for researchers. And then eventually we need to ensure that there is not much of a concept drift as well. Because what happens is long-term monitoring, if you're doing on a wearable device, the efficacy of a commercial device for a long term would be very different from a custom device. So we need to ensure that there is not a concept drift in our study. So these are some important, points to consider for a use case like this. So this kind of brings us to the end of this particular design, and hope this suffices. Thank you.